Alright, let us look at it in a different manner. Students, even before you started learning maths, you learned how to count. Let's take a box full of balls. How many balls are there? 1, 2, 3. 3 balls. So what did you just do? You counted the balls. And the numbers that you have used for counting are counting numbers. We write these numbers on a line and use dots to represent them. So, this is a number line. All the counting numbers can be written on it. The length of this line will be infinite, and there will be infinite such numbers. Have you ever wondered why we use a line only? Can numbers be written on a circle? A number circle. I'll leave this as an exercise for you to think. Coming back to our line, these counting numbers are called natural numbers. Now let's take the balls out of the box. 1, 2, 3. So what is remaining in the box? Nothing. We used natural number 3 to answer the question, how many balls are there in the box? We answered the question using maths. Similarly, when the box is empty, it has nothing. Which number in maths represents nothing? That number is 0. So we add 0 to the number line. And now all these numbers are called whole numbers because now we have covered the situation of an empty box as well. How do we add two whole numbers? Say 3 plus 5. We start from 3 and make how many jumps? Yes, 5 jumps. We reach 8. So, 3 plus 5 is equal to 8. Another example, 5 plus 7. 7 jumps starting from 5. 6, 7, 8, 9, 10, 11, 12. We reach 12. That's the answer. What if we subtract 7 from 5? Simple. We again make 7 jumps, but this time to the left. 4, 3, 2, 1, 0. Oops! There are no numbers to the left of 0. But we have to make 2 more jumps. So there must be points before 0 as well. They are again same numbers. 1, 2, 3, etc. But with a minus sign. -1, -2, etc. And they are at an equal distance as those of positive numbers. So when we include negative numbers, we get integers. So integers mean positive numbers, negative numbers, and 0. Alright, moving on. We cannot see any points between these integers, say 0 and 1, or 1 and 2, or -2 and -3. But wait, there are points between them. Take the line between 0 and 1. Bend it and make a circle. Now divide the circle into 2 halves using a diameter. We get 2 equal halves, or what we know as semicircles. So this exact middle point between 0 and 1 is half, or 1 by 2. Again, divide the semicircle. So between 0 and 1 by 2, you get half of half. That is 1 by 4. Divide again, you get 1 by 8, and so on. Similarly, you will get 3 by 2 between 1 and 2. So between integers, we get fractions. But just as there is 3 by 2, there can be a point -3 by 2 to the left of 0. Now we have to introduce a word, rational numbers, because -3 by 2 is not a fraction. Similarly, -1 by 2, -5 by 2, etc. are also not fractions. By the way, fractions can also be written as decimals. They are one and the same thing. 0.5, 1.5, 2.5, etc. So to include negative fractions in our number line, we have introduced rational numbers. So our number line has natural numbers. It has more whole numbers than natural numbers. Actually, one more, 0. It has even more integers, which includes all negative numbers, and has even more rational numbers, which includes fractions and negative fractions. Well, now can you have a circle of rational numbers? Think and make one. So all natural numbers 1, 2, 3 and so on together with 0 make whole numbers 0, 1, 2, 3, and whole numbers along with negative integers -1, -2, etc. make all the integers, that is -1, -2, 0, 1, 2 and so on. Now positive fractions, example 3 by 4, and positive decimals, which can be written as fractions, example 0.5, together represent positive fractions. And similarly, negative fractions and negative decimals make negative fractions. So, integers, positive fractions, and negative fractions together make rational numbers. So this is the complete chart of rational numbers. From this chart you understand what all kinds of numbers make rational numbers. But fractions are not negative, and decimals are same as fractions. Anyway, so we have to change the chart a little bit. Instead of positive and negative fractions, we have positive rational numbers and negative rational numbers. And positive rational numbers are called fractions. Alright, let's have a look at the concept of rational numbers in another interesting way. So we have natural numbers 1, 2, 3, 4. If we include 0, we get whole numbers 0, 1, 2, 3, 4. If we include negative integers, we get all integers -3, -2, -1, 0, 1, 2, 3. And when we include all numbers which can be written in the form P by Q, we get rational numbers. And you must know that Q cannot be equal to 0, and both P and Q have to be integers. Now that you have learned the concepts, let us put those concepts to application. I will take some examples. Number 1. If P by Q is a rational number, what is Q by P? Is it also rational? What do you think? Yes? No? Or you can't say? So let's recall the concept. What does the concept say? P by Q is a rational number only when P can be a positive or a negative integer, or 0. And same for Q. But Q cannot be 0. Now the question is whether Q by P is a rational number. Obviously for Q by P to be rational, P cannot be 0. But we don't know whether P is 0 or not. It is not given in the question. So, Q by P can be rational, cannot be rational. We can't say for sure. So the answer is can't say. But if we know for sure that P is not 0, then yes, Q by P will also be rational. Why? Because P by Q is rational, that means that P is an integer and Q is an integer and Q is not 0. So, in Q by P, Q and P are integers, P is not 0. And hence Q by P is a rational number. Next example. If we add two rational numbers, will the answer always be a whole number, a natural number? Will it be 0, an integer, or will it be none of these? The important word in the question is always. Let's find out how. Add 1 and 2. So 2 jumps from 1, 2, then 3. 1 plus 2 is 3. 3 is a natural number. So, we added two rational numbers, 1 and 2, and we got a natural number, 3. But will we always get a natural number? Add 1 and -1. We get 0, which is a whole number, not a natural number. So, no, we will not always get a whole number. We can get a natural number as an answer, but not always. So answer is neither option 2, that is natural number, or option 1, that is a whole number. Will it be 0? Option 3, because we just got the answer 0. Actually, no, not always, because we also got 3 as an answer. Will we get an integer? Yes, 3 and 0 are both integers, but will we always get an integer? No. Add 3 by 2 and 1. One jump and you will get 5 by 2 as the answer. So you have got a fraction. You can also get minus 5 by 2 as answer, a negative fraction, or a negative rational number. Which number should we add to 3 by 2 to get minus 5 by 2 as an answer? I'll leave that as an exercise for you. So, you can clearly see that when you add two rational numbers, you can get a whole number, but not always. You can get a natural number, but not always. You can get 0, but not always. You can get an integer, not always. But what you will always get is a rational number. So when you add two rational numbers, you will always get a rational number. So the answer is none of these. Alright, another example. Is 2.5 by 3 a rational number? Yes or no, or you can't say. Let's recall the concept. What is a rational number? Any number which can be written in the form p by q is a rational number. But q cannot be equal to 0, and p and q must be integers, not fractions or decimals. So the concept says that neither p nor q can be a decimal. But here the numerator is a decimal, 2.5. So no, 2.5 by 3 is not a rational number. However, we can easily convert it into a rational number. Remember division of fractions? Watch the video to revise that. 2.5 is nothing but 5 by 2. 2.5 by 3 is 5 by 2 upon 3, which means 5 by 2 divided by 3, or 5 by 2 into 1 by 3. Solve it. We get 5 by 6, and 5 by 6 is a rational number because 5 and 6 are both integers. Next example. 0 is a positive rational number. Yes or no? Recall the concept again. Integers mean positive numbers, negative numbers, and 0. So obviously 0 is neither positive nor negative. In fact, it's the only number on the entire number line which does not have a sign, positive or negative. So no, 0 is not a positive rational number. It is also not a negative rational number. It is simply a rational number. Now let's recall the circle representation of all numbers. Natural numbers, then whole numbers, and so on. Now where do I put 10 here? In which circle? Can I put it here? In the whole number circle? Outside the natural number circle? No, we cannot do that, because it would mean that 10 is not a natural number. But you know that 10 is a natural number. It is used to count things. So, 10 lies inside the natural number circle. Alright, so let's take 10 inside. In fact, the only number which lies outside this circle is… Yep, you guessed it right. That number is 0. Why? Because 0 is not a natural number. It cannot be inside the natural number circle. What about 15, 250, etc.? Both are natural numbers. Both will come inside the natural number circle. Only 0 will remain outside. Let's include the integer circle too. Now can we write 100 in this circle? No. Why? Because it would mean that 100 is not a whole number. So, take it inside the whole number circle. Now, is it correct? No again. Because now it means that 100 is not a natural number. So we have to actually take it inside the natural number circle. It is a natural number, which is also a whole number, which is also an integer. So it should be inside all of them. Actually, when you keep a number in a circle, it automatically belongs to the bigger circles. But if a number lies in a bigger circle, it does not belong to the smaller one. So, here the only numbers lying in the integer circle are negative integers, because negative integers are not whole numbers or natural numbers. They are just integers. Can you similarly write some numbers which are only in the rational number circle? Try it yourself within 30 seconds. Next application. Do you remember we divided a circle in half to explain the point 1 by 2 on a number line? Yes. How do we explain 1 by 3 using this method? Since denominator is 3, divide the circle in 3 parts, like this. Is it correct? What do you think? Do it in your notebook. Actually, no, it is not correct. When we did this exercise for 1 by 2, observe that we use a diameter to divide a circle and not a chord, so that we can divide it into 2 equal halves or parts. Similarly, if we have to represent 1 by 3, we have to divide the circle in 3 equal parts, right? And that can be done using 2 chords. So, we get 3 equal parts of a circle, 1 by 3, 1 by 3, 1 by 3. So, to represent 1 by 3, we have to divide the line between 0 and 1 in 3 equal parts. See? So, we get 2 points on the line. The first point is, yes, 1 by 3. Now, what is the second point? That you have to find out. You have to find one more thing. Can we divide the circle in 3 equal parts using a diameter? Do this exercise in your notebook. Let's see if you can find the answer. Alright, so that was the introduction to rational numbers. In the next video, we will learn how to compare rational numbers. Keep practicing. Take care. Bye-bye.